Okay, so help session on Thursday, that's tomorrow at 3 o'clock. And then to prepare for the exam, what you should do is, or what I'll do anyway, is I'll look at the 4 exams and I'll go through and I'll pick out questions and I'll say, okay, I want this question, I want this question, I want this question. And then I'll get rid of all those other questions. So I'll pick out, 50 or so questions. The exam won't be 50 questions, it'll be 40 to 50 questions, probably on the 40 end and the 50 end, but somewhere between 40 and 50 questions. So I'll pick out between 40 and 50 questions, and then I'll change them a little bit. Most of you have had me last semester. I think just a couple of you have not. And so it'll be a lot like last semester, where I take those questions and then I change them. So let me just show you, for example, how I might change. Not capture. Change a problem. Well, this is a good one. So number 6, like I might take this one, and instead of having FNet there, I might have FNet over here or somewhere else. And then you have to tell me what are the charges of the other two. So in this case, the two forces that make that up are a force in this direction and a force in that direction. And so if this is positive, that means both of these are positive because they feel repulsive forces. So you'll see a very similar problem, and in some cases it's so similar, but I've changed it just a little bit, that I'll highlight, I'll bold things, make them big font, just so that you're reminded that, oh, this question isn't exactly the same as the question out of the test. It's different. The numbers have changed, or the context of the problem has changed. Are clear on how that will happen? Sometimes I might just change the numbers. It might be exactly the same question. I might just change the numbers. In the circuits, I'll change the circuits. Usually I'll change not just the numbers in the circuits, but also the layout of the circuit, where the resistors are, where the capacitors are, that sort of thing. So I would look at the old tests, work through the old tests, see how you do on them, and make sure that you understand each question. So if you can do the old test perfectly and you understand every question, then you should be good to go. But they're not going to be identical to the old exams. But if you understand each question, then you should be okay on that, on the final. Okay? Yeah, Callie?
Oh, we won't have any question that was not.
Right. That's correct. So if there's a topic that you were not tested on, that topic won't be on the test. You have had topics that you haven't been tested on. Not very many, but you've had a few. So those will not be on the final. Okay? Yeah.
What about like concept type questions that aren't from the test? Should we still do those?
Well, it might be useful to go back and look at the concept test for this reason, that like often the concept test, you have a whole series of questions that are similar, right? Like it asks, I don't know, about electric fields. One question might ask, what happens if you change R? Another question asks, what happens if you change D? And so they're related questions, and so I might change a question that you have on your test, and it might become something like the other concept test questions. Do you understand what I'm saying? Like, I'm not just going to go out and say, I'm going to write a whole new question, and it's going to be like nothing on the exam. But sometimes I might change a question. It might be like something on the concept test. So what I would do first is just go through those old exams, find out where you're weak, where you're missing, and then in those areas, if you want, go back and look at the concept test for those areas. So like if you find that chapter 2 is really difficult, you might just skim through the concept test for that chapter. All right? Any other questions about the format of the exam? No? All right, we will we'll have that help session at 3. And then our final is at 1 p.m. on, when is it? Monday. Yeah. It's on Monday. It'll be in this room, 104. Also, after the final, you'll take an assessment. It'll be about 20 multiple choice questions that will be similar to the final. So if it turns out that you don't have time on that day, you can wait and take it the next day. But I think that everybody be sort of ready to be done with physics. But if it turns out that you just don't want to take the assessment after your final, that's fine. We'll just have to set up a time the next day to take it. You follow what I'm saying? I think that you'll be okay. In fact, I'll try to keep the exam, the final, closer to 40 questions. You should have plenty of time. 2 hours would be more than enough time. But yeah, so then you'll have plenty of time to take that assessment. And that'll be worth 15 points, up to 15 points, whatever percentage you get. That means that for extra credit, you can get up to 25 points. So you get 10 points for the concept coach. I'm going to grade that in the morning, or it's due tomorrow morning. I might not get around to grading it until later, but it's due sometime tonight, okay? Like before the sun comes up, preferably. Like I would like to start grading it in the morning when I get up, but y'all might still be working on it, you think? Are y'all all done? Yeah, okay, we'll wait till sunrise tomorrow, okay? Okay, so we'll do sunrise tomorrow for that. And, yeah, Kyle?
You take equal amount from each test, or do you wait?
Yeah, I'll take about, 10 to 15 from each test. 10 to 12 from each test. Ish. Yes, roughly equal. I think that's all. We can, if you like, go through some of the old tests if you like. Or it's up to y'all. Y'all want to go through the old tests? Sure. Okay, well listen, like help sessions, we'll treat it like that. If you don't want to do it right now, that's fine. I understand you probably have other stuff going on. But if you want to just sort of, we'll go through some of the old tests, and if y'all have questions as we scroll through, we can work through those problems. But if you don't want to do that now, I understand. I don't really want to do it either, but I'll do it. Okay? So on this exam 1, the first part is related to just static charges. So there are a series of questions. You'll need to know what static charges, how they react, how they move around, and then also how they, positive charges attract, negative charges repel. Any of these stand out to you on chapter 1? On this first page? Had the fur, the cork, the wire. Yeah, Callie?
Are you going, so you're on this first test, take some of the concept questions on it?
It had 2 concept coach questions, yeah.
Yeah,
Possibly, yeah.
okay.
All right. So anything on these tests are legitimate for the exam. All right. All right. Anything on this first page? Yeah. Number 4. All right. Doug rubs a piece of fur on a hard rubber rod, giving the rod a negative charge. What happens? Well, if the rod has a negative charge, what's that? Electrons were added to the rod. The point is here that anytime I'm charging something, it's not by moving of protons, it's by moving of electrons. So if I have the rod has a negative charge, then that means electrons have gone from the fur to the rod. So it can't mean B. It says the fur is charged negatively. If anything, the fur is charged with a positive charge. It's definitely not a negative charge. The electrons are added to the rod. That's the correct answer. D might seem right, that if you take protons away, you make the charge negative, but you never remove protons. It's very difficult to remove a proton from an atom, but it's easy to remove an electron. So you do need to know there are several questions about static charges and how they respond in certain situations. Anything else here on this page? Is that clear? Ladies? Yeah. All right. You're going to have some 2D force problems like this number 7. So I think, oh no, this number 7 actually did simplify, but you will see some 2D force problems. They will be terribly complicated, but you need to know how to add forces in 2 dimensions. Electric field lines, you'll probably need to interpret those. Set the direction on forces. Anything here in particular? What's that? Yeah, this one isn't really a 2D force problem, number 7, because the force here and here, they cancel out. So why don't we wait until when we get to electric fields, there's a 2D force problem. So when I get to that one, we'll do that one. But you'll definitely see a 2D force problem. Oh, like number 11, for example. So here in number 11, you need to know the electric field at this point. First, you draw your vectors. The electric field due to this charge is going to be in this direction, and the electric field due to this charge is going to be in this direction. All right. And now that we know the directions, we need to find the magnitudes. To find the magnitude for the blue vector, it's going to be kq over r squared. That's 9 times 10 to the 9th. Q is 1 times 10 to the minus 9 divided by r squared. That's 3 squared. This simplifies a lot. This is just equal to 1. You'll probably see a lot of easy simplifications. So not always, but I try to make the numbers as easy as possible. Then you calculate the magnitude of this vector. That's going to be 9 times 10 to the 9th. K. Q is 2 times 10 to the minus 9. That's this charge up here, divided by 3 squared. That cancels, 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 and this is left with 2. So I have 2 vectors. This one has a magnitude of 2. This one has a magnitude of 1. To find the resultant, I say 2 squared plus 1 squared. That's the square root of 5. What's that, 2.2? Yeah, 2.2. All right, so that's the answer for that one. And then in the next question, you also have to find the direction. To find the direction, we draw our vectors in a triangle. There's our 1. There's our 2 vector. This is our resultant vector. This is our angle theta. Theta is the inverse tan of 2 over 1. I don't know what that is. Let's see. Oh, it's for this question. You can figure out what angle it is just by looking here. I know it has to be below the positive x-axis, so it can't be that. It's probably B. I think it's B, 237. Yeah, it has to be B. Yeah, B is the right answer. So you find that that's equal to 63, and it's below the positive x-axis. Make sure you watch those qualifiers as to which axis. So you're going to have a problem like that for sure, either for electric fields or electric forces. Okay, folks, y'all could do that like right now if I gave it to you. Yeah, some of you maybe not, but some of you can, but you need to know how to do it because you'll have a couple of questions that are similar to that. Kinematics stuff, you're probably going to see that. Again, I haven't made out the exam yet, but like number 15, you could see some kinematic stuff. You probably will. That's probably a problem that I'll pull. So for example, here, I asked for the velocity, but a way that I could change it is instead I could ask for the distance. Don't forget your kinematics equations. You just need to know x is equal to v times t, and v is equal to a times, or excuse me, x is equal to v 1/2 at squared, and v is equal to a times t. That's our kinematics from last semester. I don't think that's on your equation sheet. I'll tell you if it is. You'll have what's on the website. No, it's not there. So you just need to know that, our kinematics equations. Probably going to see a kinematics problem, a simple one like this. Parallel plate capacitors know how to calculate the capacitance based on the area and the separation between the plates, and then know sort of what happens when you change those things, like the concept test that we had, and then also be able to deal with circuits. You'll see all 3 of those. There were several questions about capacitors here. Like number 16, that's like, what is the, if you change something about the capacitor, what happens to the charge or the voltage on the capacitor? This is just calculating the capacitance given the dimensions. And then, you know, basic stuff about what does the dielectric do, the dimensions of the capacitor. Here's just potential, knowing what potential is and how to find potential. You'll both have to do some conceptual stuff and calculations for the potential. Of course, know your units for everything. So, like for example, right here, I could change this from electric potential to electric fields, and you would need to know the units for both of those. For example, I sort of consider those similar. Okay? Know how to interpret equal potential lines. Stuff about if I change, how my potential changes. Remember, V is KQ over R. This is on your equation sheet, but on all of these, you just need to know, all right, if I change R, what happens to V? If I change Q, what happens to V? And stuff like that. Know how to calculate your potential. Remember, when we're calculating potential, we're just summing up the potential due to each individual charge. They're not vectors, so I don't have to worry about adding up the vectors. Anything in particular these past couple pages, y'all? No? All right, the next exam has a lot of circuits on it. You'll certainly see some circuits. You're going to see combination circuits for both capacitors and for resistors. Stuff like number 1 and number 2 here. Could see stuff like number 3, but probably not. You're probably going to have more complex circuits, more like number 1. You need to be able to find the equivalent capacitance, the charge, and the voltage on any one of the capacitors. You're going to have resistor circuits as well, something like this. You need to know how to find the equivalent resistance, the voltage on any one of the resistors. You need to know about power, like number 8 and number 9. Power actually comes up several times, but the power of certain devices, what does that mean about the energy that they consume, the current that they use, the charge that flows through them, the voltage that they have, all those things. There were several questions about that you'll see as you start going through them. Y'all okay on circuits? Household stuff, we have a couple questions here about households. I could take number 14 and just put completely different statements about the household. I mean, we covered several of the things here, but I could have different statements about, I suppose that. Yeah, I think so. So, no, I probably wouldn't come that far out of field. Like, since GFCI is not on here, then you're not going to see GFCI. You follow what I'm saying? But I could change up these statements, like in number 14, about your household circuit and your circuit breaker. Stuff, the similar ideas, but just written differently and asked differently. Oh, there is GFCI right there. So yeah, you can see GFCI too. Hunter? Sure. Okay, so what is the current through the 4 ohm resistor? Yeah, this circuit looks funky, but if you draw it a little bit differently, like if I have my battery here, these two circuits are the same. I have a 2, a 4, and a 10. And then I have here, this becomes a 4 ohm resistor, and then 2 4 ohm resistors in parallel are a 2 ohm resistor, so it becomes a 2 and a 10 with a 12. And I want to know what is the current through this resistor. Well, I know I have 1 amp going through here. That means I have 2 volts and 10 volts. Y'all with me? Do you first of all see how this circuit is the same as this? You sort of have to flip it on its side, and then you see that this, bring this resistor up around here, these two are together in parallel with this, and then this is in series with this branch. Okay? Now the 2 and a 10 combined, those give me 12 ohms, which means 12 volts, 12 ohms. I have 1 amp of current. which gives me 2 volts and 10 volts here. If I have 2 volts here, that means I have 2 volts here. And if I have 2 volts here, my current is V over R is 0.5 amps. All right. That's not an easy question, but you could see stuff like that for sure. Practice those circuits, because you'll see a number of circuits. Circuits are a pretty big part of the class, so you'll see probably, 3 to 5 circuit problems between the capacitors and the resistors. RC circuits, maybe, maybe not. You only had a couple questions, but you could see RC, so you probably will see RC circuits. Both knowing it conceptually what happens. Here I asked for voltage, but I could ask for the charge. I could ask for a discharging capacitor. I could ask for the current as well. So know what happens to those things on charging and discharging capacitors. Anything that stand out here, y'all? Okay. Multi-loop. Probably have a multi-loop circuit. We had a couple here. Both determining the equations and calculating the current. And then the favorite student. What's that? Yeah, it's Joseph Tolstoy is my favorite student of all time.
And also put like the favorite subject one.
Oh yeah, physics, 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 physics.
Those two need to be on there.
And version E W.
Right.
One of those, a couple of them.
All right, test 3. Magnetic fields. You're gonna have your right hand rule. So, yeah, Jacob.
Will they use the bonus questions in the test? Is there ways to find
Bonus. No, but you might have a bonus, but it'll just be something different. It'll be something that you should be able to do. I thought this last bonus was a good one, right? Yeah. So, like more people got it than they have in the past. Okay. Number 4. Oh yeah. Okay, so you had to do a couple things. First, you want your electric field, your electric force to equal to your magnetic force. Like we want them to be equal but opposite. Okay? Because the electric force exactly cancels the magnetic force. The electric force is QE. The magnetic force is QVB sine theta. Although theta is 90 here, so we'll just say that's equal to 1. All right, so this is all we're working with really, is QE equals QVB. Our Q's cancel. We're looking for V, so it's E divided by B. E was 2,000. B was 0.8. That's not 2,500, is it? It is? Okay, so A is the right answer. Okay? It looks difficult, but if you get this, that my electric force has to equal my magnetic force, then it becomes not that difficult. Make sure you know your right-hand rule. Make sure you know all those various equations for calculating forces and magnetic fields as they come up on this test. Because not all of that was on this test. Like there were some topics that we left off, and like we said earlier, if they were left off this test, they won't be on the final. Okay, y'all good on your right-hand rule, all that business? Yeah, you'll see it, I'm sure. And then getting into light, know your EM spectrum, electromagnetic spectrum. Here I asked about frequency, but it could be energy or wavelength. Make sure you know it, all 3. And I could give different kind, like gamma rays, microwaves, visible light, that sort of thing. Know the history of light, what each of these people thought light was and why. Newton, Einstein, Huygens, and Young. know your basic reflection stuff, basic refraction stuff. You'll likely have some of these for both. How does the light refract and reflect? Okay, any of these? I think this part of the test is probably a little simpler than others, but some of these word problems get difficult, like 24. Yeah, no, good. Okay. As far as ray diagrams, we only had the concave mirror and the convex lens outside the focal point. Similarly, that's what you'll have on your final if you have them. I could draw them incorrectly in different ways, but it'll still be the same setup. That's what I told you in class we would do. Y'all follow what I'm saying? Like I might draw the incorrect ray incorrect in a different way. All right, that's exam 3. Exam 4, you just got back. Anything stand out for exam 4? I don't usually go on over the exam the day of returning it. Anything stand out for exam 4? I'll take a second to look at it. Number what? Sure. Y'all like the longer exam? Okay, so what is the wavelength of this wave? Well, L is equal to 3 meters. And the wavelength, one full wavelength, goes from here to here, right? So if L is equal to 3 meters, that means each of these increments is 1 meter each. So this has to be 2 meters. So D has to be the wavelength. You follow? And then the harmonic, that's the third harmonic, right? Because this is my first harmonic, and then I add this to be my second, and then this will be my third. Anything else from this test?
Do you know like the other parts of the ear?
Yeah, the basic parts that we talked about, yes. So you need to know, yes, the auricle, the ear canal, the tympanic membrane or the eardrum, the ossicles, and the cochlea, and the exhalation tube, and the auditory nerve. Yes. Yes, I'm sorry. Y'all need to know that anyway, because most of your biology majors, right? So if you don't know it yet, you need to. Alrighty. Same with the basic stuff, the larynx, the trachea, the lungs, the diaphragm. Okay. So, 16. Okay, probably going to see one like this, and this is probably one of the more missed questions on the test. Here I want to know the distance to the second dark fringe. This is a single slit problem. The second dark fringe is right here. That's m equal 2. So I say a sine theta equals m lambda, and I solve for theta. That's the inverse sine of m lambda over a of 2 times 610 times 10 to the minus 9 divided by a, which is 0.2 times 10 to the minus 3. And that works out to be, does anybody know right off? They have that on their test. What is it? Do you have it, Brent? 0.92? Okay. 0.92 degrees. And then once we have that, we have the angle, theta. I want to know why. Why is it? What's that?
I'm sorry, I gave you the answer.
Yeah, theta's
I'm sorry.
5 degrees.
Oh, okay. And then y is L tan theta, which I assume that's 0.92. 0.92 times 10 to the minus 2 meters. which is going to be 0.92 centimeters. Okay, so you have to first find the angle theta, making sure you get your order number right. The order number is 2. This is our wavelength in meters. This is our slit width in meters. And then once you find theta, you can calculate y. All right, is that clear? Okay. Anything else for this stuff? Listen, tonight, take a look at those 4 exams and then come to the help us tomorrow with your weakness areas we'll work on. Tomorrow at 3. I'll let you know the room. Have a great day, okay?